We're sitting down with Theori, another AICC competitor. That's the challenge where you have to create an autonomous system to both find bugs, patch bugs, deploy a patch, and then confirm that it's fixed. And this went over a 2-year contest. We have content on talking about what it is. However, we're sitting down with one of the teams right now, hearing about what was their method, what worked, what didn't work, what was surprising. But starting off, you're not new to DEF CON.
No.
You've been doing this a long time.
Yeah, so I'm Tyler Nicewander, Tyler NI7. So yeah, I think I started attending DEF CON in maybe 2010 or so. Every year I've been here, I've played in DEF CON CTF. I have basically never really walked around the conference. But in 2016 and this year in 2025, I played in the Cyber Grand Challenge and then the AI Cyber Challenge, in addition to the CTF. And yeah, so I play CTF first with PPP. PPP is merged with our company Theory's team, form MMM. So I played with them. We've won the DEF CON CTF 8 times and placed second most of the other times. We got 7th our first year, but after that, it's been first or second. So. Yeah.
When it's like the Super Bowl of CTFs, that is remarkably impressive.
Yeah, the Patriots, maybe not this year, but you know, or recent years.
Let's jump into the AICC.
Yeah.
So you heard about this. Was your first like gut check like we need to do this? It's a CTF.
Yes and no. So our first, when they first announced it, they announced it at DEF CON in 2023, and we're like, this sounds interesting, but we were kind of like, I'm gonna wait to figure out like. I got to read up on like exactly what it is. And it took a while. I mean, if you think about it was like 8 months after ChatGPT was announced, right? This is still early days of the LLM hype wave.
AI.
Yeah. So we waited a little while and then we're like, okay, like I see what yes, okay, we're making patches, we're producing like POC kind of exploit things. Like, all right, yeah, I get this. This is our thing. So then we're like, yeah, of course we'll throw our hat in the ring.
So you join.
Yep.
You get how does the contest start? It's like, here's the problem. Here's how you start.
Yeah. So for us, we kind of like read up on the rules, try to get it, and it's a little bit weird, right? You play a CTF, it's nice. There's like you get a challenge and a scoreboard, and you can kind of just start doing stuff. For this, it's like, all right, like open a text editor, and like I guess I'll just start coding. So yeah, we. Honestly, we didn't really do a thorough reading of everything that we were supposed to do, so we kind of made a more general approach and then kind of whittled it down, which I think was good for us because it is something a little more extensible, and we're happy with that. Yeah. So
you said that you had previously competed in the Cyber Grand Challenge, which is kind of the predecessor to this. Not really.
Spiritually,
we had talked to some of the other teams who had also competed in the Cyber Grand Challenge, and they reused some pieces of their framework from that. Did you find yourself doing that as well, or you wrote everything from scratch for this? So with the exception of like the existing tools out there that
I guess there are two things. So one, when I competed in the Cyber Grand Challenge, I did it with another company, but the other thing was like, so my background is like kind of vulnerability research, fuzzing type stuff. I love fuzzing. That's what everyone used in Cyber Grand Challenge. I don't want to do that again. Like it's cool. It's a good area, but I'm very hyped about LLMs. I'm not like those hype people, but I'm very excited by what they can do. And really for us, it's like, if we're going to do this, let's just go all in, right? Let's see what we can do. Like if we try the really cool LLM thing and we can't qualify, then all right, that's not. But if we can do that and that works, then that's what we're going to put all our effort in. So that's what we ended up doing.
So I want to get into the technical details.
Yeah.
So you obviously have this pipeline. Yep. You have an orchestrator which is moving it along. You have LLMs you can pull from. Can you walk me through? We'll call it your platform.
Yeah.
Stuff comes in. I always see it as data comes in, data comes out. What is the maneuverability in the morning? So how did data come in?
So yeah, so when we start off, so we get basically a repository. Like it's not exactly a Git repository because they've wiped the commits for the large thing, so we can't use this extra because they might inject a bug. They don't want us to do a diff. We can't use the internet to do a diff. We have to look at it fresh. But we get this code. So our system, we literally use LLMs for static analysis. So we will feed every single function in the code, is there a bug? Is there a bug? Is there a bug? Now, if you're thinking about this, like, it sounds cool, and then you're, okay, but like, if you get a function and you're like, is there a bug? Like, that's not enough data.
No, not at all.
And so our I guess kind of like our insight here is like, it's okay if that's shitty, if some of the results are accurate, right? So most static analysis tools, like if you ever used, like not
They
even
work
just,
the same way.
They're all some sort of regex, semgrep.
yeah, and so like they all have these false positive rates of like 99.9 plus percent. But if you're a human, what you do, like you kind of get it, like you do vibes, you do intuition, like, oh, that's some junk, that's some junk.
You're like, oh, if the input into this function is a null, it'll crash. But
Yeah, but that's stupid.
no one's ever going to send a null into this. And if they do, it'll crash. So
Right.
There's a variable which has the word password in it, and there's a string stored to it. It's obviously.
And so the nice thing with these LLMs is like they get this. I mean, I'm going to anthropomorphize a lot here because it's easier to talk about whatever. If they can use intuition, right? Like if they see like cookie, okay, like I don't need to write a regex that says like if a cookie is used in a stir copy, then that's a bug. It's like cookie, that's user controllable input, could be attacker controlled. So if that's passing into a bad thing, that's a bug. And you don't need to hard code this because they've been trained on the entire goddamn internet. So they know that. So it's a really powerful tool for this static analysis, with the caveat that you get a shitload of false positives. So the next thing that we do is we use LLMs again, basically all in on LLMs. So we use LLMs to filter those out. And so like, you start off with this kind of top of the pipeline, as cheap as possible, just get results, filter them out a little bit as cheaply as possible. But now if you can remove, let's say, half the false positives, you get half the results. Now you can spend twice as much money on the next stage of the pipeline. So we keep doing this. You whittle it down a little bit. You get a little bit fewer results. You up the resources investigating it. And you could keep doing this until at the end of our pipeline, we get about 50% false positives, which is like, okay, for every one bug, you get one fake bug. That's fine.
Yep.
And then we feed that off to yet another LLM that actually produces an input. So it walks through like I would as a CTF player, being like, okay, I want to get to this function. Who calls it? Who calls that? What checks are in the way? Okay, let me hook up a debugger that didn't work. But that is a little bit more expensive because that has to run. We run a few in parallel because some of them fail, but that costs like, say, $35. But you can't run $35 on 10,000 false positives. But when you whittle it down all the way to the bottom, you get 10 things. I can spend $300. That's okay.
So
yeah, I mean, for even static code analysis, like check marks or whatever, you're spending way more than that for an application.
Yeah, exactly.
Did you use? It's so interesting that you're like we just went all in on LLMs. A lot of the other teams were like, oh, they pulled in the static code analysis tool. Did you use any open source or any commercial static code analysis?
We used one tool. Facebook Infer. I know they're meta now, but it's still Facebook Infer is the name of the tool. Theoretically, it runs on C and Java. It was too annoying to work for Java. So literally for Java, the only thing we have is LLMs. And our team did the best performance at Java of anyone in the competition.
And you used for the static analysis specifically that meta tool?
So for that one, we couldn't use, like, it supports it theoretically.
Gotcha.
So we used it on
C. Gotcha.
Yeah, and even on C, when we were looking, like, after like we run a test run, our database has nice little annotations about like who found it. Mm-hmm. I would say more than 2/3 of the things were not the static analysis. It was just a pure LLM solution.
Wow.
And some of they can report the same thing sometimes. And so sometimes it's whoever won that race, but usually it's just the LLMs. It's just mind blowing.
That is mind blowing.
So I know from talking with some of the organizers, it was the quality year one.
Yeah.
You had an LLM budget of like $100.
Yeah.
That must have been a challenge for you in particular, because a lot of the teams we talked to, they were like, they were very precious about how they deployed that $100 budget. Mm-hmm. How did you qualify when?
Yeah. So for the qualification, it was a little bit easier. So part of this, like that pipeline I just described, that's what happens if you get a repo of like 1 million lines.
Yeah.
The qualifier, it was all diff based, where they were like, here's 200 diffs.
Gotcha.
And maybe 5 of them have bugs. So that one, like a diff is easy because like, okay, that's a few hundred lines that are relevant. So that's a much scaled down problem. so it was still tough to meet that budget, but it was a little bit easier than this one.
So when you were going, so things coming in,
Yep.
you now LLM to LLM to LLM.
Yep.
You now have narrowed it down to what you think is a bug.
Yep.
And I'm guessing, again, it was all the way to turtles all the way down.
Yeah,
it's LLM to find what you believe is a bug.
Yep.
What were the next phases after that?
Yeah, so as soon as we get one of these like bug candidates or whatever, like high confidence bugs, so we start trying to do this exploit generation thing, and we start patching it in parallel. And that's a little bit risky because if you patch it and you've never seen an example of like this is an input that triggers it, that patch is unlikely to be great. But you know, you like LLM fix this bug. I can't tell you what the bug is exactly. So what we do is we do that just for latency purposes. So the idea is we'll do that, we'll kind of stick it in our back pocket, and then as soon as the actual like exploit generation thing runs, we're like, okay, well I already have a patch, let me just test it. And if it tests clean, then
even if your success rate on that is 25%, you're still moving faster.
Yeah, exactly. And if it didn't work, then we're like, okay, well now here's the input that you failed on, like go retry. But yeah, and that's, you know, the patching stuff, I think, you know, when we started this in like 2024, that was a little bit like, oh, this is cool, like agentic coding. You know, in 2025, everyone's like, yeah, of course, agentic coding, we all know that. It's the same basic idea. So.
What's interesting to me is when we were talking to one of the teams earlier, they were saying that they expected LLMs to be really good at patching. I thought LLMs were going to be really good at patching, but really poor at vulnerability or bug discovery. It's interesting. It almost sounds like you've flipped it.
Yeah, I mean, I think it's mixed, right? Part of this is, you know, if I'm so again, my background's in vulnerability research, right? The way that this normally works, you look at some code as a human, you find a bug, and then you're like, all right, this is the bug that I'm working on. And if you think like fuzzing or even symbolic execution, a much fancier technique, that's not what they do. They're like, I will generate a new input, and my new input will take a new path, and maybe that crashes. And it's kind of like a dartboard sort of thing, and like they can be better about like, I will make sure that it does a new path, and that's
I'll get
more
some feedback,
efficient.
I'll get some branch data, and you know, I'll optimize for new branches, right?
Exactly. Yeah. So there's techniques to make the exploration better, but they're exploration strategies. They're not, this is a bug, I will exploit the bug. And you
it's almost a bidirectional search, right? Like you find the failure point, and then you're working your way backwards rather than forwards.
Bottom up instead of top down or something. Yeah.
So you now have a remediation. Do you use the LLM also to make the PR?
Yeah. So we don't need to make a nice like GitHub PR, but we actually kind of do internally, because for the whole thing, we already have an English language description. So we've reported like some of the stuff that we were doing in testing. We've already reported like, I don't know, a few dozen bugs upstream. Like some of them were like a heap like out of bounds heap right and like SQLite that's you could trigger.
Nice.
And looking at the bug, I'm like, this completely unfuzzable bug. Mm-hmm. It was they fixed it on Monday, and it's like I didn't really look at it. I just kind of copied and pasted because we get a nice bug description. We get like, here's the lines, here's the root cause, here's the thing that triggers it. Easy, like they fixed it in 2 hours after we reported.
That is amazing.
It strikes me that one of the pieces that is so frustrating to the industry is you'll have these, you know, VR. I was also doing VR a while back. Now I'm doing Linux development. There is a divide between people who are very good at VR and we'll say the domain experts of whatever it is the VR people are fuzzing.
Yeah.
So often we say it's like you go in as a security team and you want to help someone secure their software, and it's more like kicking their puppy for X amount of weeks, right? I'm here to kick your puppy and make you sad and work for you. In this case, I can imagine a world where the VR experts are setting up a system like this, and it's generating patches. And, you know, on the Linux side, it all runs on, I'm going to send a patch via email to a group of people who presumably know whether or not will be a good patch, right?
Yeah.
And they'll look at it. But there's usually a divide from a security person who knows how to do the VR stuff and those domain experts. This kind of bridges that in a lot of ways, because what you just said is just like, I'm not really sure. I know we have an input that crashes this.
Yeah.
I'm not really sure how to go about fixing it or whether this patch is correct according to the domain experts.
Yeah.
But it's enough for them to do it.
Yeah, so I'll say when I submitted stuff, I didn't submit our AI generated patch. I was a little like, I will give you everything up to. I was like, I don't want to.
There's license issues with that, right? So
That's
there's
true,
still
yeah.
open questions about how to. Which, by the way, Linux just they're working on their how to. You're required to put a code developed by tag with the model information in it now, which is really cool. I don't think it's upstream yet, but they're working on the language in the license.
Yeah.
So yeah, it sounds like there's going to be a path to figure out how to do that.
Yeah, like when I reported them, I was very clear because like it's hard because there's. So our tool, like this is not like I whipped something. I just like copy pasted the code in the ChatGPT and it told me there's a bug, and now I'm going to report it for a bug bounty. This is like a pretty serious engineering effort, and so it's like, okay, yes, like I'm a human being who knows what's going on.
Yeah,
I want you to fix this.
It's not the problem of just shoving it all.
Well, I mean, there was that. What was the
curl?
The curl maintainer. And that's a real concern.
It is a real concern, absolutely.
I think one of the biggest problems we find with systems like this, or even the thing is like it's not. Yes, there is a bug there. It's not exploitable. It's not reachable.
Yeah.
How did you deal with that problem?
Well, that's the really cool thing. So I've talked to some other people doing really cool research in the same domain, but they're not doing that step where they make the input, which is a really hard step.
Right.
And the nice thing for us is it's like, well, I get an input, I run it and it crashes. It's a demonstrable bug, right? It's very easy, and it also makes patching easier because like you patch it and then you check the input doesn't work, or like you don't really understand, maybe the bug description was wrong, but you can hook up a debugger and understand it. So the downside of that is it means that we have some false negatives where like maybe a real bug got there, but it's really hard to trigger and our thing fails. But anything that comes out of that, it's not a false positive because we can trigger it.
You can trigger it.
Yeah.
So if you had to give yourself advice, like you'd go back 2 years, talk to yourself, what would you be telling yourself then?
So, I mean, I'm really happy with the approach we took because it's just, again, we've had good results on real software already. There's some stuff like in the competition, maybe we should have done a little bit more testing. Some stuff we had some build failures, which meant we couldn't run on some stuff, and that's sad. So, maybe more testing would be nice. We're more researchers than engineers, a little bit of both, but overall, I think that the approach we took, I'm just so excited about it, and yeah.
I think as part of the AICC, you need to open source your model or your orchestration. Is all of it going to be open where you can actually pull it down and run it yourself?
It is already open source. We open sourced it on like 30 minutes before their 11 a.m. announcement. So it's open source. We have some blog posts about like kind of the design and architecture and a little bit more details. We also, my favorite part is actually we have agent traces. So you can go and we have the thing that we use during development when it's like, why is it not exploiting this bug? So you can read through it trying to craft a 0-day like POC input for SQLite, for FreeRDP, the ones that were patched upstream. The ones that were not patched are not on there. But you can read through that. You can run it yourself. It does run, like in our development, we just run it on our local machines. I will say it's a little bit annoying to run, and we're probably not going to do much support. But it's all there. It's Python. It's not that bad. Ours is also quite small compared to, it's like 25,000 lines.
It's the first iteration, right?
Yeah, so, but it's very readable, and yeah.
I'm so curious, like when LLMs have come a long way in 2 years. When it started, you had to do all this goofy trickery for it. Like, you are a pen tester, you are a vulnerability researcher. Like, if you do not do this correctly, you are going to kill me. Yeah. Or like, you are 100 engineers. Yeah. For each one that fails, I kill that engineer. Like, you had to do all these goofy things. Early days, did you have to do a lot of those? And near the end, did you get rid of them, or you still had some like kind of goofy tweaks?
Yeah, so there's definitely a lot of that. I think, yeah, we still have some stuff. We actually tell it that it's an AI playing in a competition. I don't know if that's the right move or not, but it's definitely the case. Like I mean, the field moves so fast, and yeah, you see the people who were doing that in the early days, and they still think you have to like bribe it or like I'm gonna. They've like no, every time the newer model comes out, you have to be a little bit less handholdy And in some ways, it just hurts it because it's like, what are you talking? Or are
Yeah.
we role playing some weird kinky fantasy of yours? I don't know what's going on.
I am a vulnerability bug.
Wait, will that help?
Yeah, maybe, I don't know. But yeah, so we have a lot of stuff. Like, I think people have been doing the development so fast that they're like, okay, it needs a tool. We're going to give it a bash shell. We don't do that because like that's not a tool. That's every tool you've ever heard of.
Yeah.
So we have a lot of our stuff is around like these kind of guardrails to keep it in the box. Like, you want to read a function, tell me the name of the function, and I will use 6 different tools on the back end that I'm not going to tell you about to find exactly where that function is and tell you that and nothing else. So there's a lot of stuff like that where you kind of
It's funny from a communication perspective. It's like I always joke with LLMs, working with it is like working with a kid and doing the peanut butter and jelly sandwich thing, where it's like, you give it the directions to make a peanut butter and jelly sandwich, but the closer, you have to be very precise about exactly what the requirements are, and the closer to the precision that you get, you eventually just end up writing the code yourself in a lot of ways. So it's kind of interesting from the patch generation perspective. We know that, and talking with a lot of previous teams have said this too, there isn't really a tool that has done that before. Maybe it's done little things like change a greater than to equals to or less than or things, but there's not really something that could generate a whole relatively complex patch that maybe changes the boundaries of an array or a read, or changes a stir copy to some other completely different function. Did you find in the early days it was a lot harder to do the patch generation compared to towards the end of the competition for that reason?
So there's a little bit of that. So our patch generation, so one of the things, if you talk to people, both the other teams, but even like the cutting edge AI labs, generating like a diff, it's bad.
I've tried. Yeah.
So our approach, which is a little bit weird, but we ask it to generate a diff. It generates a pretty shitty diff, and then we have a lot of stuff to try to clean it up. So part of this is like, they have seen a lot of diffs. There's so many diffs in the training data, but they don't understand numbers. Like, if they give line numbers, it's nonsense.
Yeah.
So we do. It's a fancy algorithm that you use for like DNA alignment. Like, if you're trying to like align 2 strands. So we use that on the code, and we say, okay, here's the code that you said, like the context and the lines that you're deleting or whatever. We do an alignment there. So this gives us a thing where we can align the patch without needing the line numbers. And it's fuzzy enough that if it hallucinated, we can still match it. And then we have a second pass where we say, okay, this is where you're clearly trying to edit, and you hallucinated a couple of lines here. So like, now we can go back and say, excuse me, you just pretended that there was a curly brace after that if statement. There's not a curly brace after that if statement. You can't just add an extra line there.
So
that happens so often. But this technique, it's not perfect. We didn't solve the problem, but yeah. So, and also some of the newer models, I think GPT 4.1, when they announced it, they had a big long section about how they worked real hard on generating diffs and making better diffs, because that was right before Codex or whatever came out. So it has gotten better, but we still use that. It still does hallucinations that we still catch, but it's like the failure modes are a little bit less. Yeah.
What, as kind of a final question, what models did you find when you were going through, like, this one worked really well, this one worked not as well?
So we use a lot of different models, mostly Anthropic and OpenAI models. So we I mean, you could see in our code, but we use a lot of Sonnet, a lot of GPT-03 and 4.1 and 4.0.
Those were provided, right? There's no way to do self-hosting.
Yeah. So the nice thing about this, like, they didn't give us internet, but like CGC was air gapped. There was like complete. They made a big show of it. This one, you couldn't use the internet. Like, they set up like some firewall rules, and they had someone manually inspect it after we lost access to make sure we were obeying. But we had full access to LLM APIs, so it was pretty cool because we've tried using some of the local models. We haven't tried like there's models every goddamn day. We haven't tried the ones
just too big. You need a rack.
Well,
right?
our company, we've got we've got terabytes of VRAM.
Fair
The
But
other
yeah.
piece too is what you end up finding is you end up just becoming an engineer to work with all the different APIs,
Right.
and then people get frustrated. And they're like, okay, well, this is silly. I'm going to use LangChain to like do it, and LangChain's kind of jank. to
We
begin
ended
with.
up using we use like some light LM, some kind of meh library to just genericize the
model interactions. Yeah.
But we don't use anything for like people talk about agents like it's this big thing. It's a for loop around calling the LLM API.
Yep.
So like we can write a for loop ourselves. So we wrote a for loop.
How dare
ourselves.
you give away the secrets?
So I shouldn't have said that.
Yeah.
Delete that. Write that.
I know you need to get back to the CTF contest
Yeah,
right now.
yeah.
But I wanted to, as a final question, just what you gave advice to yourself is what is the plan for this? What you've done in the future? You said you're not going to support it. Are you going to grab it and keep working on it as under something else?
Yeah, so our company again, Theory, we are a commercial company, so we do plan on trying to make money. Sorry, guys.
No, you should.
Yeah.
That is what the
It's awesome.
contest is
Yeah.
about. That's why I'm curious. Like where are you going to keep working on it? Are you going to are you thinking
So
about
we're
productizing it?
trying to productize it. Part of it is just trying to figure out how, like it's a totally different thing from the traditional way of doing stuff. So like that's really cool, but it's a little tough because like if you buy a license for like a static analysis tool, it's like you get to click the button to scan as many times as you want. We can't quite do that because you got to pay some LLMs every time you scan. So trying to understand where the balance is, but like even this false positive pipeline, like if you already use static analysis, you got to deal with this crap.
Yeah.
And so maybe even that part is something commercially
I
valuable.
mean, my first intuition was, there's already a variety of kernel fuzzers that Google and Intel and all the different, big companies are running on the back end on every major pull request to Linus on the kernel, right?
Yeah.
It seems like, that's a well-packaged set of diffs. Seems like a good place that you could start to just insert yourself into a system like
That's a good
that.
point, yeah.
And it's just, you're probably going to get a lot of false positives, but as long as everyone understands that, it's going to be useful. It's probably going to find a lot of stuff, which would be interesting.
Thank you for your time. Thank you, Theory. Thank you for competing and the team. Thank you for watching.
Yeah, thanks for having
And
me.
hack on.